This is a talk largely about the NHS spine, the health service in England. I'm Matt Barrow. I'm from London in England. You could probably tell from my accent, or as the taxi driver pointed out this morning, I won't do the accent. But as I got in the car, he said, "Ah, I knew you were English. You dress like Jeremy Clarkson." So, good start. So, National Programme for IT. What was it? It started in 2002. It was seen as a government initiative to bring together all the systems, all the healthcare systems in England. So we wanted to connect up some 30,000 GP systems, 3,000 hospitals, in the region of about 10,000 pharmacy systems. It was a big piece of work. The budget to start with, about £3.5 billion, and that grew over time. But that was the first scope. Contracts were awarded in 2003, early 2004, to a number of big systems integrators, who you might have expected: BT, Accenture, CSC, Fujitsu, those sorts of organisations. So amazing, it's a big thing for patients. We had 50 million records, lots of systems connected up. It's great. Wasn't a huge success. There were fairly publicised failures. We had a number of challenges from the Health Select Committee, the Public Accounts Committee, and the King's Fund. In particular, the chairman of the Public Accounts Committee put this as his title to the report that went back to the House of Commons, our government in England. So it was seen as a really big concern. It wasn't great. And by the end of 2009, 2010, it was really coming apart. So the English government at the time said that they weren't very happy. We had a change of government, change of organisation. There was big concerns about what was happening. And come 2011, we put the stop on it altogether. So the Daily Mail on the 22nd of October 2011 just announced that the programme was gone. And this has been a very, very public, very big failure as far as the NHS was concerned. Even yesterday here, is it Goiko? Apologies, I've pronounced the name wrong. Asked how long it would take to flush all 12.7 billion down the toilet, 20 pounds at a time. So we spent some time yesterday evening just working it out, thinking what it might be, and it's in that sort of region. Sorry, hang on. Go back. Yes, so 3,000 or just over 3,000 man years was what the answer was. So 35 people working for 100 years to get through it. It's a scary number, but it's not scary when you consider it in the context of what BT claim was spent on just spine, just the element that connects the national systems up together, the national database and everything that goes with that. 15,000 man years was what they claim. And this is in this case study. You can still see online now. They haven't yet removed it, or maybe now, but not of last night. And this number is even more scary when you put that into context that this didn't include development. That was just for management, preparation, organisation, everything that goes around it. Yeah, big numbers. Yeah. So. They also highlighted a number of things in the same case study. It had been such a great job, only 15,000 man years to deliver this program. So they highlighted that they'd taken this approach, they delivered it around the world. And of course, what we know now, 10 years on, is that there's a couple of minor inaccuracies with the statement. Largely that waterfall delivery on this scale was much avoided now. So since then, I've worked on a number of other big programs, and the idea and the learnings 10 years ago about how we would do this are very different to what they are now. And trying to go into a program of 10 years of work. Sorry. We did use Prince 2. We had a lot of Prince 2 practitioners, not me, but there were a lot of Prince 2 practitioners, and this was part of this. It just didn't work. Now there were a number of things that did come out of the program that were good. It wasn't all a failure. There were some really big numbers. Some of the things they achieved, business change on a very large scale. It was in many ways a big success. Not everything was good, but some good things there. There were two big problems though. The first problem was in release and change and how we do that on this sort of scale. Program started off, great idea, every 3 months. Now 3 months for the purist agile people among you seems a long time to do releases. In a healthcare environment where you're dealing with 1 million staff, it's quite frequent. This is a good cadence to be able to achieve. Of course, it was software delivery, so we didn't achieve that. Started off at 6 months, and then what happened was the authority, the government got concerned. Why is it taking 6 months when we said it would take 3 months? Something must be going wrong. There must be some problems with the software. So let's put some assurance framework around it. Let's do some process. Let's do some extra testing, service management change, transition change, and then all of a sudden our 6 months got to 12 months and greater. The last couple of releases took 18 to 24 months to deliver. But then, of course, what we found was that 12 months is a really long time between releases. When you're paying a transition manager or a change manager or those sorts of roles, you have to add all of their salary onto every release. So 12 months very quickly became never. And it got to a very bizarre position where it became known as the gold-plated iPad, which is this. So what we found is that where users wanted to improve the service, where they had an idea, they wanted to make it better, it became cheaper and easier just to give them gold-plated iPads than fix the service. And there was a real scenario we had. We went to speak to the back office administrators who sit in an area called Southport. We talked through the problems with the system, what was good, what was bad, how we could make it better for Spine 2. And we were expecting fairly detailed changes. We could make the process better like this, we could change this, we could do this with our business. Actually, what we found out was that the number one requirement they had was when they entered some data at the top of the screen and clicked tab, it went to the next box instead of the box at the bottom or the box back at the top. And changing tab order was too expensive to do in Spine 1. The second problem was live support. So obviously, it was a big program. We had lots of connected suppliers who were providing services. Some are names you'll recognise, some you'll like. And then each of those organisations had their own, the usual team, the usual people you'd expect to be in that position. So your sysadmins, your firewall managers, all the sort of traditional roles that would have been there 10, 15 years ago. But then, of course, this is a government organisation that was running it, so we had to add in assurance. And with assurance, you have to man-mark everyone. So you can't quite see, but double the numbers everywhere, add on a whole overhead for assurance. And what this meant was that live support became a ridiculous thing. 24/7, every day of the year, we had 150 people supporting the service. An army of people to run the thing. And this was seen as a real problem for us. So Spine 1, in summary, there was some really good stuff. It achieved some really good things. There were some hard engineering problems that they had to overcome, and they did overcome them, and they did very well with it. But there was a lot of room for improvement. And when it came to the end of the contract, 10 years in, we spent well over £1 billion on Spine 1. We had to replace it. The idea at that point, we were deep into austerity measures in the UK, and replacing it with another £1 billion contract just wasn't going to work. So Spine 2. And we talked to the senior members of the organisation about what we wanted from Spine 2, how we wanted it to work. They came up with some good ideas. Like for like but better was one of my favourite ones. It has to be exactly like the current system, but just better. We wanted to use things like commodity hardware. We didn't want big, expensive Oracle rack, specialist hardware, XML hardware acceleration. These weren't things that we needed anymore. We wanted to make it faster. Cheaper was an important one, so orders of magnitude cheaper. We didn't want to be 5% cheaper, 10% cheaper. When we talked to the big systems integrators about doing Spine 2, we said, well, it's £1 billion, so they spent the £1 billion bid team. The £1 billion bid team came along and said, yeah, it looks like it's £1 billion project, but you're a good customer, you're a government, so we'll do for you 10% off. We'll do it for 900 million. And this wasn't okay. And so the other thing, Agile, is something that at the time, this was 4 or 5 years ago in UK government, it was being proposed as an idea. It was not really seen to work on this sort of scale. Certainly things like Scale Agile Framework weren't adopted in the UK, and there was a real concern about how this might work in reality. So we looked at Waterfall versus Agile for the program. Largely, the team that were working on it, we're quite keen to try new things. We'd seen all the problems with Waterfall. We didn't want to go down that route again, but we had to identify some of that. So we called out some of the key things. We knew there were complex interfaces. To put that in scale, I think at the latest count it's maybe 800 different message types. Some of those are quite simple, some of them are very complicated. So you can request all the prescriptions for your pharmacy, which could be in batches of 25. You can do some very complex searching for 100,000 patients at a time. So some of these are quite tricky. We know also that the government, the central government, were very against doing waterfall. Very against doing agile. But the elements of the sort of the team were saying, this is heading in this direction. So people were starting to produce papers within government to say agile's okay. So we had a bit of support there. We knew that the requirements were very changeable. We'd seen over the last 10 years that when the program started and the 2 years spent requirements gathering, this was traditional in a 10-year waterfall program, they were mostly wrong. So probably 50% were out. But what was worse than that was the specifications. We had upwards of 100,000 pages of specification, many of which were wrong. They were all right at the time they were written, but of course, that time had passed, and you had to build up using a number of different change notes, request notes, to actually work out what the system did. So we appreciated there were some good reasons. There were also some good reasons not to do Agile. The perception within the organisation was very negative. Agile was seen as a way to avoid documentation, as a way to avoid doing process. To be fair, there was a couple of times we did use it as an excuse, but for the most part, it was it was seen as a bad thing. 90% of existing was the MVP. We didn't have the option to deliver small chunks of functionality. We couldn't go in with something that wasn't like for like or almost like for like. There was a lot that we scrapped. 10% of the functionality represented a fair bit of work. 1,500 man years by BT standards. So there was a lot we could chuck out, but most had to stay in. No end user consistency. There was a famous quote we had once from one of our leaders. Who explained that the problem with the NHS and the problem with MPFit is you ask 5 clinicians for an opinion on something, you get 7 different answers. And the final one was the myriad of processes. So we had lots and lots and lots of different processes. There was a process for everything. Making a cup of tea, there was a process for it. Everything had a process that was written down, had to be followed. So this was a real challenge for us. So we ended up with what we terms of lowercase agile. We didn't want to be purist agile, and actually similar to what Carl was saying previously, we took the best bits of different things we were looking at. So there were areas where we knew that our first release was going to be after 3 years, but then we went back to every 3 months after that. So our subsequent releases were every 3 months. In reality, we were much faster than that. So first month after go live, we did daily releases. Going forward after that, it's been more like sort of weekly, fortnightly releases, but very frequent. We had fully automated tests, but again, instead of doing the sort of traditional test pyramid, lots of unit tests, very few integration tests. Integration was our big risk. We knew that was the big area of concern. We had so many interfaces and so many connected systems. So we did the pyramid upside down, focused very heavily on integration tests from the start, and then worked backwards from there. We had operational simplicity. What we chose here is that we wanted the live service to be easy to run. We didn't want 150 people working on a shift in live. We didn't want to have to be a case of, this piece of the code's broken, who knows about that piece of the code, let's call that person. That wasn't what we wanted. So we deliberately chose developer complexity over operational easiness. We made it hard for the developers. One of the prime examples of that is we used Basho React for the database. It was a perfect choice for the demographic service and for the clinical service, where we had lots of data being stored about patients in one place. It was much harder for the prescription service, where you needed to do things like release 25 prescriptions at a time and work out how to batch data. So we knew that was hard. It would have been easy for us to choose something like Postgres in prescriptions, but then we would have doubled our technology straight away. And linked to that, we then had this fairly fixed infrastructure, fairly fixed architecture, fairly fixed patterns. We didn't want to be in a position where developers were just deciding it as they went along. Appreciate this is again fairly anti-agile, particularly anti-Spotify, but it was what worked for us. We knew that we might change the technology, we might move away from Basho into Mongo or Cassandra or something else, but at the time that was what we were doing. And if we chose to replace it all, we replace it wholesale, not bit by bit. Improve, not remove. We appreciated that with all the existing processes around the organisation, around HSCRC as a group, but government as a much wider thing. We weren't going to be able to stop these external processes. We had to fit in with them. So one of the things we focused on very early on was assuring the process, not assuring the release. Each release we did, we knew we were going to be pushing it out the door quickly, and traditionally the assurance team would look at it. They would run 3 weeks or 4 weeks of testing. They would do some clinical assurance. Service management would get involved and check it was okay, check the documentation and so on. It just wasn't going to work when we wanted to do hour and a half releases. So we challenged that, and we got them to assure the process of doing it. Understand our definition of done, understand how we transition code to live, and get confidence from that instead. And the final point then, we made sure that our environments were representative across the board. We knew that we wanted to use commodity hardware to have simple code, so we worked on the basis that what we had deployed into test environments was the same all the way up to get that consistency. On that point, there was again a story from one of the early Spine releases that went wrong, Spine 1 releases that went wrong. It was a very manual process to deploy and configure the code. There was one release where there were 2 pages stuck together, and the release went horribly wrong. So other things we did, self-documenting code. We didn't want the 10,000 pages. We wanted it to be a case where anybody could go into the code at any point and understand what was going on. As part of this, we had 4-week sprints and 3 sprint releases. So every 12 weeks we would put the code to live, and even during the initial 3 years where we weren't live, we put it into a production-like environment, so it was out the door, ready to go, ready to be operated, just to get into the rhythm, into the cadence of doing that. We started using Scrum-ish. It wasn't really Scrum. It was kind of Scrum. It was the bits we wanted. Later we moved to Kanban once we got to live. Again, Kanban-ish, not really genuine Kanban, but it was bits we wanted. But we did use Jira, Confluence, and Jenkins as everybody does these days. We stuck with physical card walls for the most part. We had a small team, so physical walls worked for us very well. In terms of the team themselves, then, we had 35 multidisciplinary engineers. We were very keen not to have developers or testers or platform engineers or these sorts of things. We wanted people who could be, across the organisation, so they could do all the different roles. As part of that, we were very keen on sort of a flat organisation structure and collaboration. So I was there as a lead role. There were others who were in sort of similar positions, but we cycled around the team. So I was developing, I was testing, I was doing all the roles that you would expect as part of the team. And when I was doing a test role or a development role, I had a sole lead that I was reporting to, and we'd work around on that basis. The belief and commitment to doing it right, this was an important thing, something we tried to instill throughout. That when you're working in a health service, it's very easy to understand. We all have parents, family who use the health service, so it's quite easy to get to the point where you understand that if you make a mistake, somebody might get harmed, and it might be somebody that you know, or somebody who's important to you. But more so, in many cases, we highlighted that developer and operator were the same thing. So we were running the service as well as developing it. So if somebody made a bad commitment, well, then they had to fix it. And don't be a muppet. This was something we had to try and keep a bit more interesting. So we had a definition of done, very clear definition of done. And if people didn't follow the definition of done, if they put code into develop that broke it, well, then there was a muppet that got put on their desk, and they had to sit with the muppet on the desk until the next person broke the build, and then they got the muppet for a period of time. Now, it was a bit of fun, but actually it served a really good purpose. It focused people on making sure that they weren't doing stupid things, they weren't getting it, because it was a source of embarrassment. If you had them up on your desk, well, you'd done something wrong. And the result, well, going back to what we said about Spine 1 initially, the sort of key points, 15,000 man years to develop. The release is taking months to plan and days to execute. 3,000 servers, many specialist appliances, 150 man support team, and many specialists. To compare that then to Spine 2 and where we got to, so less than 100 man years to develop it from start to finish. We had that team of 35 at peak. Normally it was less than that. We don't know the total number, but we know it was less than 100 man years, so much smaller number. Releases for us were hours to plan, and actually in many cases it was much less than that. It was we need to put this out, we need to fix something, we just need to do it quickly, and minutes to execute. It was a case of click the button, go out, get a coffee, come back. The release to live was done. There was no ceremony, there was no concern. It just happened. It was quiet. 3,000 servers became less than 100, and all commodity hardware. Now this was a really important point to us, because historically we had to have expensive call-off contracts, 3 hours contracts, 2 hour contracts, And they are very, very expensive to get somebody to commit to fixing a service in the middle of the night within 2 hours. For us, we had spares. We had a box of spares in the corner. We could just pull out a server, put a new one in, wait till the next business day, replace it with a new one. It was no problem for us. Our 150-man team was three. We had two more people who were on call at any time, but actually they rarely get called out. And the two people that get called out are just developers. They're on call during the week. We cycle around each week. Everybody takes it in turns, and we only have three people on site doing operational monitoring, running batch jobs as they need to happen. Anything just to make sure the service is running. You're bearing in mind that we're running at we're still for 1 million users, 1 million plus users now, and a few 100,000 messages an hour. And the final point, so many specialists, we got away from that and just worked much more in generalists. So this is part of the previous point about the support team. If something broke in the demographic stack, we didn't want to have to find a demographics person who was on call. We just wanted to find somebody who could fix it, one of the engineers, anybody to fix it. So the other benefits. Release costs dropped by 99.99%. Sorry, just 19. Sorry. In release cost reduction. So what this meant was that it became a lot easier, and we didn't have the gold-plated iPad scenario anymore. We could then say to the organisations, well, what do you want to do? We'd like to try something out, but we don't really have a business case for it. Well, don't worry about it. There's no cost to put something live. Let's put it in. So we started to have this platform of change come back in. We could make changes, we could try things out, we could see if they worked. If they didn't work, well, we just changed it the next day. It didn't matter. Our availability since go live 99.99. It actually this includes planned downtime. If you take out the planned downtime, you have to go to about 6 nines before you get to to the point where it doesn't round off to 100% anymore. So it's a very, very reliable system, very stable system. And the downtime we had for transition, bearing in mind that in Spine 1 transition, often you'd have a weekend of outage or many hours of outage. For Spine 2, when we transitioned over, we had 5 minutes of downtime for the prescription service, nothing for the other services, and since then everything's been zero downtime plans. And failure tolerant. As I said before, we didn't want to be in a position where we had to plan for all scenarios, all failure scenarios, and work around that. We wanted to have a failure tolerance built into the system. So the way we did this is we have blue-green stacks. We have multiple sites. If we have a problem, we can move from one to another. We use canary releases. We can work around it. It just doesn't matter. If we have a hardware fault, we have enough resilience both at the database level and within the technology to move away from those. So we don't have to think about all those possible scenarios. We don't have to engineer all those possible scenarios. We just tolerate it. And then the output of this. So 2,000 or greater than 2,000 messages a second, running 90% faster. Well, that's a big deal. It actually equates to 750 days of working time saved for the NHS every day. So a really big figure. So this was announced recently by the one of the health secretaries, and it's been quite a key figure for us. Beyond that, the first year saving, 21 million. Again, in the grand scheme of the numbers that we had for Spine 1, 21 million isn't a huge number, but it's big. This also includes all the money that we spent on preparation, on development, on buying the hardware to put it live. That all came out of that. So 21 million was just our first year. We expect it to be much bigger in the second year, third year, fourth year, and so on. Now, I'll talk briefly about quality adjusted life year. The quality adjusted life year is the way of measuring in the UK whether a treatment is good or not for a patient. And it's a very simple calculation, A times B, where A is the number of years of life gained for a patient given a particular treatment, and B is the quality of life of those years. And fairly importantly, 1 is full health and 0 is death. So if a treatment costs £10,000 but gives a patient 1 year of full health, well, that would be £10,000 for that quality adjusted life year. We have an organisation in the UK called the National Institute of Clinical Excellence, and they define, or they used to define, the value of a quality adjusted life year at £20,000 to £30,000. So if a treatment or a medication costs £25,000 and gave somebody a full year of health, then that would normally be agreed. It's since been qualified that should be dropped to £13,000 on the basis that technology is cheaper, treatments are cheaper, drugs are cheaper. So actually 13,000 is a better number. And that, when we overlay it back on the original 21 million, is a much more important value. 1,615 quality adjusted life years just in the first year of operation. So in that year, having spine 2 instead of spine 1 allowed for 1,615 people to have a full year of full health through other treatments. And importantly, as we said to the developers, for every developer, every engineer that worked on the project, well, that's greater than 46 quality adjusted life years each. And going forward, so we don't have to do any more. We don't have to have any additional input to keep that going for 5 years, 10 years now as the service runs. These numbers will keep rolling up as we go through. What went wrong? I started writing this last night, and I thought I better put some stuff about what went wrong. There was about 22, 23 slides by the time I got to what went wrong. A lot. So as we went through, we learned a lot of lessons. We did the full inspect and adapt. We learned the hard way in many cases. There were things we wanted to do, didn't do very well. But that's probably another presentation in its own right. I think it's too much to talk about here. If you want to ask any questions afterwards or speak to me during the break, then you're welcome to do so. But there were a lot of learnings that we picked up on and took forward into other projects we worked on. And so that's it. Email address there. You feel free to speak to me during the break.